So my name is Eric Munoz Garcia. I'm an application scientist here at CID Bioscience. I've been with the company for 2 years. I have a background in molecular biology and chemistry. And so, yeah, I'd love to hear about you, Ronnie.
Yeah, I've been following your webinar a couple of times actually. So that's why I'm familiar with your name and your face. So yeah.
Oh, great. Yeah. That's
Yeah, so my name is Rany. So now I'm PhD student in University of Reading in the UK, but now I live with my husband in the Bay Area in the US. And previously, I was working for a chocolate company for Mars. Since this project is under collaborations between University of Reading also Mars. So I just resigned last November from Mars. So my last role is Senior Agronomy Scientist for Southeast Asia. And then now I'm just focusing on finishing my PhD dissertations. And then I was experiencing using your equipment, the CI-110, since 2015, maybe. Yeah, 2015, 2006, or 2016, maybe 2016. So previously I was using the old CI-110.
yeah.
uh, and then in 2018, I get the latest model one from CI-100. And then so then I can compare the difference between the old versions and the latest. And then now my research project is about maximizing the efficiency of novel cropping system on the cocoa productions in intensive growing systems. So long story short, it's like making a vineyard system for cocoa.
Oh, okay.
Yeah, so then with manipulating that architecture, we are hoping to get more efficient and then maximize yield on cocoa. For having that analysis, I need to have instrument for measuring the light interceptions and then leaf area index. So all the canopy characteristics, which is involving CID equipment, the CI-110.
Yeah. Oh, I understand. Yeah, that sounds so exciting. If you don't mind, could we talk a little bit about some of the treatments, maybe?
Yeah.
Yeah, I would love to hear about the treatments that you
Okay.
use.
So we use two local Sulawesi clones. We call it MCC02, MCC01. Um, and then both of the clones, they have different vigorosities. One is really vigorous and one is quite small, related to the trunk diameter. And then it was planted in different architectures from 1, 2, 3, 4 branches. So can you imagine that normally cocoa trees has 4 branches, but we cut all the main branches into 1, 2, 3, 4. Some of them are um, shaped in a trellis, and some of them are in just conventional planting or architecture. And then some of them are in a high density, high planting density from 2,000, 3,300, and also 5,000 trees per hectare. And then some of them also planted in different row orientations in the east, west, and north, south um, row orientations. So why we have different row orientations? Because in the previous experiment in Apple, you can refer to Jackson 72. So when Jackson and Palmer planted the apple orchard in a different row orientations, in temperate locations, that they observe the estimate percentage interceptions by the east-west hedgerow is varied over the seasons. However, for the north-south hedgerows, it was reasonably constant. So that's why there's a different results that they have with different row orientations. So that's why we want to see whether it will influencing the light interceptions, and then later on will influencing the yield that we have.
I
Uh,
see.
and then for um, higher planting densities, so higher tree densities, improving the efficiency of light interception per unit area, and usually in other species or crops has other favorable effects on the higher harvest index. So that's why we want to see beyond the conventional planting density. That is usually 1100 trees per hectare. That's the conventional way to grow cocoa. So then we
Mhm.
want to go beyond that. 2000, 3000 until 5000. So we hope that with this higher planting density, not only it will improving the productivity per hectare area because we multiply it by the numbers of the tree, right?
Yeah,
But also it improves the efficiency of the light interceptions. But uh, another possible challenge that will occur, it might be the efficiency or the productivity per tree, whether it will be decreasing with the higher planting densities, since it has nutrient competitions between the trees. So
yeah,
we want to see about that. So the latest result shows that there's limitations of planting density. So we cannot, until now, we cannot go in 5,000 trees per hectare planting density with certain cocoa clones.
I see. So you see a drop off at 5,000 trees?
Yes.
Okay. Conventional is 1,100, you say?
Yes.
And
So
so,
the convention is 1,100. It's usually 3 by 3 or 4 by 4. But what I use is the minimal of the higher planting density is 2,000 trees per hectare. So the trees that grows in 2,000 trees per hectare, planting density seems growing quite well
mhm.
with that cocoa clones. But as you may know that there's also interactions between clone and planting density. So not always, although I say that the cocoa tree that growing in a planting density 2,000 trees per hectare could grow well in certain clones, it might not be suitable for other clones.
Yeah, I see. Okay.
Yeah.
Uh, North, south to east, west. Are you able to
Mm.
talk about that? Any of those?
So, yes, I can share about that. Since until now, we cannot see any difference, whether it's growing in the row orientations, east-west or north-south, whether it's located in Indonesia, or I have also some results from my colleague in Latin America, in Ecuador. They also found the same thing. So why the results in apple is different with cocoa, maybe it's because of the locations itself, since the apple research located in the UK, so and then we are located in a tropical area, so my trial located 3 degrees from the equator, to be
I was
exact.
about to say, yeah, if in a
Yeah,
temperate environment, you're getting uh, or closer to the equator, you're going to get much more stable sunlight. Um,
but there's one effect that we see is about the sun damage on the pots.
uh-huh.
Although east, west, and north, south, they have more or less the same light interceptions, or light interception or intensity, but during the day in the north, south, the pots will receive more or less constant constant light compared to in east west. In east west, since we are located in 3 degrees from the equator, there's some area that is quite shaded in the afternoon. So that's why the pots will not receive the same exposure as in the north south. So that's why in north south we found some pots that looks like burn because of that sun damage, and it will induce pre-germinations, since each clone has different characteristics of pulp. Some of them are quite humid, some
Mhm.
of them are quite dry. So if the pulp is drying, so that's why it will induce the germinations process. So this sun damage process will induce pre-germinations for certain clones if it's exposed to the sun in the longer exposure time. So, for
Yeah,
instance, in the north south, certain clones will have pre-germinations because of that light exposure.
I see. Okay, that's interesting. For myself and any viewer as well who's not super familiar with cocoa, can you talk a little bit more about the sample itself?
So cocoa is a perennial tree. In conventional way, it planted in a tropical area, and then in conventional way, it usually planted with distance 3 by 3 or 4 by 4. In Africa or Southeast Asia, usually one family farm only has 2 hectares. They planted it in 3 by 5 or 4 by 4. So then in one area, they more or less have 1,000 trees. Since most of the cocoa producer country is in the tropical, as you said, so the biggest producer is Ivory Coast, and then Ghana, and then continue with some countries from Latin America. But
Mhm.
as we know that most of them are coming from the smallholder farmers. Productivity, it really varies within the country. In Africa, the highest that's recorded is around 600 kgs per hectare, while in Southeast Asia, usually it quite higher, more or less 800. But then in Latin America, in a bigger farm, the highest that I heard is about 2 tons per hectare.
Wow.
Mm.
Interesting that you mentioned, the small stakeholders in production of cocoa.
Yeah, so it tied also to the culture itself. How in Africa and Southeast Asia, it's really difficult for industry also to have a large cocoa farm compared to in Latin America, because the culture in Latin America is they have they used to have a big farm for coffee or for cocoa, so that's why it's quite easy for them to continue that culture, that big farm culture. While in Southeast Asia or in Africa, normally one person or one family farmer just had like 2 hectares farm, and it's difficult to have a bigger farm, because the culture is like family on a farm, so
Yeah,
it's difficult to gather all the family into one big farm. And then the equipment itself, it's really easy to use in the field, the CI-110. And so that's why, even though there's a like drone equipment now that can facilitate to also measuring the same thing like leaf area index measurement or light interceptions, but the CI-110 equipment, it's I think it's still the best approach to measure that parameter that we need, especially if we work with really small farm. My project actually located in Indonesia, so that's why we want to see how local Indonesia clones will cope with that intensive growing system in that vineyard or orchard systems. Um, Meanwhile, if as you know that in Latin America, most of the cocoa farm is in a big farm, just like 200 hectares area.
oh,
So
nice.
if we are working with a larger farm, so for instance, if I had my trials, it will cover like 100 hectares farm, and then I want to have an idea about the leaf area index or light interceptions data. So I will choose a drone imaging one. But if I need to have a project that will go deeper into the analysis about the possibility of using certain clones to have specific measurements, so I will use this handheld equipment ones, because the point of this research is to maximizing the productions in orchard system. So then we will use smaller vegetative growth. So then we hope that the harvest index will goes up to
Yeah.
reproductive if we decreasing the productions of the vegetative growth. So that's why leaf area index parameter will be one indicator to see whether this clone is vigorous or not. So that's why it become one of the most critical equipment in my trial. Mm.
And with that, I think I really appreciate your time, all your wonderful work uh, in Cacao, as we look forward to seeing the publication.
Mhm. Thank you
Thank
also,
you.
Katri.